You know, every single time you snap a photo, or unlock your phone with your face, or even just check the weather, you're tapping into this incredible hidden world. It's the world of digital image processing. Basically, it's the science of teaching computers how to see. And today, we're going to dive into how this tech lets us see things way beyond our own senses, revealing what's really out there. Okay, so take a look at this image. When you see it, your brain just gets it, right? You see the shapes, the colors, the objects. It's all instant. But have you ever really stopped to wonder, what does a computer see when it looks at this? The answer? Well, it's probably not what you're thinking. It sees this, a giant grid of numbers. That's it. It doesn't see a picture or a cat or anything like that. It just sees data. See, every single number you're looking at corresponds to one tiny little dot, what we call a pixel. And that number tells the computer its exact color and brightness. And believe it or not, this grid of numbers, it's the foundation for literally every single digital image that exists. So to get just a little bit technical for a second, what you're really looking at is a mathematical function. Think of it like a graph. The x and y coordinates, well, they just map out the grid, right? And the value of the function at any one of those points? That's just the brightness. And each one of those points, each number in that massive grid, that's our good old friend, the pixel.
All right, so what machines see? From pixels to perception. Now the big question is, how do we get from that simple grid of numbers to something as complex as a self-driving car navigating a busy street? It's a huge leap, right? Well, it's a journey, and it happens in a few key stages, with each one building on the one before it.
Okay, so here are the steps. It all starts with what we call low-level processing. This is like the basic cleanup crew. Think of it as just sharpening a blurry photo or getting rid of static or noise. Then we move up to mid-level processing. This is where the machine starts to recognize things. It sees a big cluster of pixels and goes, hey, that looks like a car. It's starting to label stuff. And finally, you have high-level processing. This is the big leagues, the world of computer vision. This is where the machine takes all those labels and puts the whole scene together to actually understand what's happening.
Okay, next up, an invisible rainbow, seeing across the spectrum. And this is where things get really wild. You see, our eyes can only pick up this tiny, tiny little slice of the electromagnetic spectrum, what we call visible light. But with image processing, we can build machines that see the whole shebang, the entire spectrum, and they can show us things that are completely, totally invisible to you and me.
Let's start at the super high-energy end of things with gamma rays. Now, in nuclear medicine, this is basically a superpower. It lets doctors see the invisible. By picking up on these faint gamma ray signals coming from inside a patient's body, they can create these incredible images that show how cells are working or not working. This is how they can pinpoint diseases like cancer with just mind-blowing precision.
Then, of course, you've got X-rays. We all know these from getting a broken bone checked out, right? But what you might not know is how crucial they are in manufacturing. They're used to peek inside a totally sealed-up gadget, like your phone, to spot a tiny, microscopic flaw on a circuit board. And the best part? They can do it without ever having to crack it open.
All right, moving along the spectrum, we get to infrared. And infrared lets us see something really cool: heat. From way up in space, satellites are using infrared to track the heat coming off of clouds and oceans. Why does that matter? Well, it's absolutely crucial for tracking huge, powerful weather systems like hurricanes. It gives us those early warnings that literally save lives.
But hang on, what happens when it's super cloudy or foggy? You can't see anything, right? Well, that's where microwaves come into play. Microwaves are the powerhouse behind radar, and radar can just blast right through all that stuff, clouds, fog, you name it, to map out what's on the ground. It doesn't matter if it's day or night, rain or shine, it just works. And finally, let's jump to the other end of the spectrum and talk about radio waves. These give us another absolute marvel of modern medicine, the MRI. You've probably heard of it. By using powerful magnets and radio pulses, MRI machines can build these unbelievably detailed maps of our soft tissues, our organs, our muscles. And the really amazing part is they do all this without any of the dangerous radiation you get from X-rays. Okay, Section 3, from messy to meaningful, the processor's toolkit. So being able to capture all these images from across the spectrum is, incredible. But the raw data, it's usually a mess. It can be blurry, full of static, or just plain distorted. So to turn that messy, raw information into something we can actually use, image processing has this whole powerful digital toolkit.
Just look at this. A lot of the time, the raw image you get from a sensor looks like the picture on the left.
It's noisy, it's blurry, it's not very useful. But then we can apply these clever algorithms that basically act like a digital cleanup crew. They get rid of the noise, they sharpen up the details, and boom, you get the crystal clear image on the right. This is exactly where that digital toolkit works its magic.
But that's just the beginning. The toolkit has a lot more tricks up its sleeve. For instance, there's a technique called segmentation. This is how a computer can look at a crazy traffic jam photo and draw a box around every single car. It's dividing the image into meaningful parts. And then, something called morphological processing can kick in to analyze the shape of those objects, which is exactly what you need if you want to, say, automatically read the license plate on each of those cars.
All right, next section. Our world processed. Look, all these amazing tools, they aren't just for scientists in some fancy lab or doctors in a hospital. The truth is, the ideas behind image processing are completely woven into our everyday lives. Seriously, they're all around us, usually in ways we don't even notice.
Just think about it for a second. That banking app on your phone that lets you deposit a check just by taking a picture of it, that's handwriting recognition. How about when your phone's camera magically finds and focuses on all the faces in a group photo? Yep, that's face detection. You've got iris scanners at the airport, automated systems that can read license plates, even the quality control that checks every single pill or bottle coming off a production line to make sure it's safe. It's all of it, powered by these exact same principles.
So this brings up a really interesting, almost philosophical question. If you have an X-ray, an infrared picture, and a regular photo of the exact same thing, which one is the real one? Well, as our source material brilliantly points out, that's just the wrong question to ask. The quote puts it perfectly. An image is just the interaction among three things: the wave hitting the object, the quality of the object, and the receiver quality. None of them are more real than the others. They're just different ways of seeing. Each one is its own valid truth. So here's where we are. We're building machines that can perceive the world in ways that are, frankly, impossible for us. They can see right through walls, they can see across entire galaxies, and they can see deep inside our own bodies. And as this technology gets more and more powerful, it really makes you stop and think. It forces us to ask this really big question. As these machines learn to see our world, what are they going to show us about ourselves?